Hey y'all, sorry to be late. Hopefully you got my message. I was just finishing up a midterm in 465 and it slopped over a little bit. So I should be able to get us started, however, pretty much right away. Can everyone, first of all, should have just shared my screen with everyone. Can everyone see it?
Yes.
Yep.
Okay. Very good. Okay, give me 1 second. I need to get something to drink. Okay, so let's get started. Agenda for today is I will be resuming in-person classes on Tuesday. Online is still fine. It's not required that you come to class, but starting Tuesday, I will be back in Mingal giving the lectures there. So if you want to show up, you're more than welcome to show up. Also, I will be hopefully offering a in-person final exam option. So for those of you who just despise Respondus, I will allow you to take the exam in person in Mingal. Second thing, someone made an excellent point that, well, it made me realize an excellent point. So on homework 6, I was making it due Sunday night or Monday morning, and thinking that you'd be able to get then started on the next homework, but the next homework is on Python. We don't even start Python until Tuesday. So I've pushed the homework 6 deadline back 2 days. So now it's due effectively Tuesday evening. And then I pushed a whole series of deadlines back by 2 days, except I can't push the final deadline any farther. So the last assignment, you'll still get 12 days on it, which should be enough. Hopefully that will also alleviate a little bit of pressure for you on this deadline, because obviously we're just finishing the material for it today. Looks like the regrades are done. The median stuck at 67. So I'm going to add 10 points to everyone's midterm grade. That may not get done today, but it will be done by tomorrow. So by sometime tomorrow, you should see 10 additional points added to your midterm grade. Some of you will end up over 100. That's fine. Just want to reiterate, when I say that I'm bringing the average up to 77, and that is, I view that as a good average. Want to reiterate, I give a B for average performance in the course. What I found is that the homework assignments and the pre-class activities will have such high scores that they will offset a 77 average, and anyone who gets at what is going to be likely the average for the pre-class and the homework assignments, their average will pop up above 80. And I don't give B minuses, I just give Bs and B pluses. So that means that if your average is above a B or 80, you'll get a B in the course. So just because the midterm and the final are likely to average around a 77, that doesn't mean I think 77 is a C. It means that my experience is, given what everyone else will average on the remaining part of the course, that will be enough for people who get right at the average to score a B for the course. Okay, in fact, score a B comfortably. It won't be like they're on the line. It will be that they're a number of points above the cutoff.
Dr. Van der Zanden,
Yes.
does that same no minus thing apply to you don't give A minuses?
Correct. I don't
Thank
believe
you.
you either get a or a B or a C or you don't. I mean, yeah, or you get a plus. I just don't believe in minuses, so I don't give them out.
Thank you. That's awesome.
Other questions? Okay. I was about to do a video going over the remaining questions on the exam and realized I'd gone over the 3 hardest and longest questions and that the video was going to take about 5 minutes. So I decided instead I will do a 5-minute review of the remaining questions on the exam. Then last time I didn't get to sprites. It was the one thing in the lecture I did not get to, so I'm going to talk about those maybe today. I think I'll do the MVC model first because that is what is most important for your homework assignment, and I did not ask you to use sprites on your homework assignment, so I'll probably dive right into the MVC.
I have a really quick question about homeworks.
Mm-hmm.
I was looking at the later homework assignment, and in the grading guidelines, it says that there will be like extra credit points if you fill out the evaluations.
Yeah.
Is that still going to be a thing for this semester?
Yes. Mm-hmm. It will be.
Okay.
That will be a good way to get points at the end. I always forget, the points vary from class to class how many I give, so I'm not going to promise you how many points because I have to look at that. But yes, that will be available to you.
Okay, thanks.
You're welcome. Other questions? Okay. So
I'm sorry.
Oh, yeah,
It took me a while to get unmuted.
No worries.
So for problem 2, do we have to match your behavior exactly?
Pretty close. What are you talking about? So just a second, let me run it, okay? And
Okay.
you can tell me what it is about mine that is, or yours that is different than mine. It's like I have to figure out where it is.
I didn't mean to derail the class. I was just.
Actually, can we handle it after class?
Sure.
Yeah. So we'll handle it after class. Okay. So like I said, let me go to the exam and not there. Okay, so yeah, that's the sample exam, isn't it? Okay, here's the exam you did. Okay, and so the first one was GUIs. Most of you got the first one right. The type of component used to create a Java window is a JFrame. The type of widget you should use to select a state in the US when there's 50 of them. So you may remember I went over, first of all, there's basically 3 possibilities here. There's radio buttons, a menu, and checkboxes. So I only wanted you to select one state. So that means checkboxes are excluded because they allow multiple choices. And I said, if the number of choices is 5 to 7 or less, it can be all fit into working memory and also doesn't take up too much of a footprint on the screen. So you use radio buttons. If it's more than 8, but a bounded number, and generally that bounded number is around 100, it turns out. So probably between about 8 and 100, you use a menu. Above that, you're pretty much going to have to use a formatted text field. So this was in the sweet spot for a menu. And so that was the correct answer. Now, to exactly show you another example where the number, so Social Security numbers is also bounded. There's only I shouldn't say only, there's a billion of them. That's the problem. So it's impossible to present any list that's going to have a billion numbers on them. So the only way you could input that would be through a formatted text field. So that was the best choice there. The type of widget you should use to show a matrix of data. So a JTable is perfect for that kind of thing where you're basically, in fact, I had to come up with some other word than table to avoid giving this one away. So rows and columns should make you think of a table. And then a J label is used when you want to convey a piece of information that should not be altered. The book is sometimes using J text fields for that purpose and setting the editing flag to false, but that's not the generally accepted way you display non-editable information. The way you do that is with a J label. You can also display images, bitmaps, JPEGs with a J label. So they're a general purpose widget for displaying information. Okay, question 2, pretty much everyone got it except for the type of garbage collector that explicitly counts the number of pointers to an object. That's a reference counting. So reference counting is essentially you're counting the number of references to an object and garbage collecting it when there's no longer any pointers to it. So that was pretty much the only issue on number 3. And then on number 6, you were asked to do a bag class with 2 type variables. And there was only a couple issues here. First of all, I said it has 2 lists named bag 1 and bag 2. And about a third of you declared those bags as array lists, but that's not what I asked you to do. I wanted you to declare them as lists and then assign array lists to them. And that way you can change the implementation very easily down the road, say to a linked list, without having to change a whole lot. So you had, I think, 2 points deducted if you declared them as array lists rather than lists. The only other real issue here, let me go to the solutions. Most people got the add. The only issue with find, so the simplest way to do it, for those of you who have not experienced with the index of function, index of will return the first occurrence, the index of the first occurrence of the value, and -1 if it can't find it. So that was the easiest way to search it. I was fine if you wrote a for statement where you basically said for I equals 0, I less than the size of bag 1, if the value matches at some index, you had the index and you return bag 2. A couple of things I did not like. Maybe 2, 3, 4 of you continued your search. When you used a for loop, you continued searching after you found the index, which is both inefficient and it really gives you, if there's duplicate values, it gives you the wrong index because you'll find the last instance of it rather than the first. So that's not good. The other issue is that some of you knew about index of, but were still using contain. So what was happening is some of you would say if bag 1 dot contains value, and then you would show me that you knew about index of, because you would say return bag 1, bag 2 dot get, and then many of you would say bag 1, not many, but it's few, index of value. So the issue, you got 1 point off for this, and the reason is you've got 2 linear searches. Index, that one costs you an order n search, and this one costs you an order n search. So you had 2 searches of the list, which was unnecessary. You only want to search the list once. And at this point in 365 and the upper level courses, they're kind of like finishing schools for 302 and 140. We want you in these courses to still be applying the efficiency principles that you learned in those two courses. So double searching a list is not a good thing to do. Instead, I wanted you to just search it once and return the value. So that I just wanted to point that out. You got 1 point taken off as a nuisance. It's irritating, but I want you to be focused on efficiency on these things. So those were the only real things I saw with 5. It had pretty good results. Most of you ended up with 16 or more points on it. Okay. I'll take questions about the exam after class, just because I really want to get to the MVC model, make sure we get through it, in part because it's not easy, but it's so fundamental to what is done in industry these days that you really need to understand it. So the model view controller is called a design pattern. A design pattern is something that comes up repeatedly for multiple types of problems. And it especially comes up with graphical user interfaces. So MVC stands for Model View Controller. And the idea is that you have a number of views, and the views are your GUI. So you have a number of views that might display the interface in different ways. So in assignment in the homework, you're entering a value, and there's 3 different, between 0, well, actually between a min and max. And there's 3 different views. One is a text view that allows you to type in the value. A second is a increment decrement that allows you to increment or decrement slider. And then the third one is a gauge view that allows you to sweep a dial back and forth. So there's 3 different views, and they are all setting some state information in what is called the model. So in the homework, you have a min possible value, a max possible value. You have a current value, essentially. And you have an increment. So those are, in effect, we call it the state information. So the model stores what we call the state info or information, and it's supposed to be devoid of graphics information. So that's all supposed to be in the views, devoid of graphic. Now, sometimes it's unavoidable. If you're running a drawing editor, obviously there's some information about drawing in the model, but generally anything that has to do with presentation goes in the view, and you try to make the model devoid of the graphics. And then theoretically, each view has a controller that is mediating the interaction between the view and the model. So the controller is responsible for event handling. So the view is doing presentation. The controllers are handling event handling. So when some event occurs on the view, they call some kind of information on the model to change the model. And then the model sends back some notification to the view indicating that the state of the model has somehow changed and that the view needs to update itself. The controller does not do this because it is possible that the change will be rejected by the model. So the controller never notifies the view that the change has occurred. And when the change occurs, that notification method is called for every view, not just for the view where the change initially occurred. Okay, so actually I will go to the homework assignment for a moment so I can illustrate this fact. So here I've created, this is the homework, and I've created something where the minimum value is 50, the maximum is 100, the start value is 80, and the increment value is 5. So for example, if I change, I can't change the text, it's read only. But if I change the slider, you see that the value of the text is changing and the gauge is changing. So it's not just the slider that's changing, it is the gauge and the text as well. And here, if I move the gauge, you can see that the slider and the text are updating. So updating one view means that all three views should get updated. So the controller, for example, for the slider, notifies the model a change has occurred, the model updates its current value, and then it sends notifications to each of the three views telling them to update themselves. Now in practice, the idea originally was that controllers should be reusable and should be independent of a view. That is, you could create instances of controllers and attach them to multiple views. But in practice, that turns out to be next to impossible. So in practice, it turns out that we tend to combine controllers with their views. So see if it's going to let me, probably not. I want to change the color. I think it's going to force me to use, I want to use red. Let's see if it'll let me use red. Yep, it will. So in practice, every controller tends to be bundled with its view. And in your homework assignment, that is what you will do. You will bundle the controller with the view. Okay, so this MVC model is pretty ubiquitous in the development of interfaces. And the reason it is because you want to allow new views to be created or views to be modified or views to be deleted without impacting the other views or the model. So you want to get this isolation principle. So that's what you get with APIs. When you publish a public interface, you can change the implementation without modifying the API. And that's kind of the same principle that's going on here, is a separation of concerns. The computation for the model is encapsulated in the model. The presentation of each view is encapsulated in that view, and then the event handling is encapsulated with that view as well. And if I decide to modify view 2, it doesn't have any effect on any of the other parts of my application, which also makes it easier for different people to work on different parts. For example, here, you could have someone who works on the model, someone who works on view 1, someone who works on view 2, someone who works on view 3, and they all work independently of each other. Okay, so questions thus far about what I've talked about? Okay, so this isn't what normally confuses everyone. It is how you actually set stuff up in practice. So in practice, there are going to be a number of different classes and interfaces. So in practice, you're going to have a model class. So there's going to be a class for the model. Then there is going to be one class for each view. And I'm going to say controller because, in fact, you're going to have to pretty much combine the controllers and the views. Then you're going to have a glue class, and that is the class that contains main. So it contains main. It creates an instance of the model and view classes and links them together. So every view class has to have a pointer to the model so that it can query the model and get its state information in order to display the appropriate state information for the model. The model needs to have a list of its view classes so that it can notify each of them when a change to the model has occurred. And then the fourth ingredient is generally we call it a view listener interface. And it is an interface, not a class. And it is the way by which the model notifies the views of changes. So contains methods that allow the view, or I'm sorry, that allow the model to notify views of changes. So sometimes it's just a generic notify method and the view has to figure out what the change is, but more often for more complicated models, it will give there will be multiple notify methods depending on what part of the model has changed. So if it's a game, then there might be multiple parts of the game that will notify the views of changes. And sometimes the views don't even care about a change. So if you have, for example, a game, and you might have, so the game might be some kind of board game. So that might be view 1. And view 2 might be a score, might be a scoreboard. So they're actually tracking different parts of the model. So the model is going to have both the board information and score info. And only view 1 cares about the board info, and only view 2 cares about the score info. So there might even be, view 2 would probably have a null method body for board info because it doesn't deal with it. And similarly, view 1 would have a null method body for score info, so because it doesn't implement it. So each view implements that interface. So coming back here, the view listener interface, okay, all views implement it. And it should be in a separate file. So each of these is in a separate file, including the interface. Okay. So essentially 4 different kinds of classes or interfaces that you need to set up. And each of them has some well-defined methods associated with them. So let's take a look at that now. So with the model, the methods are going to be as follows. First of all, there has to be query methods associated with the model. So the model wants the views to be able to access its state information. For homework 2, the models need to, the views need to be able to query the current value, the minimum and maximum value, and the increment. So those are the query methods. They return information about the model to the views. Then it also has to have methods that allow views to register and deregister with the view model. So when a view registers with the model, you typically add the view to a list so that when there's a change, the model, the model can iterate through the list and call the appropriate notification method on each view. And remember, those views are implementing a listener interface so each of them will have the appropriate method that needs to be called. Then you also implement change methods for the controller that change the model state. So in the gauge that you're doing for the homework assignment, the gauge and the slider will both want to set the value of the model. And sometimes the model rejects the change or modifies it. Let's say that the slider, for some reason, doesn't account for the fact that the value should be maybe between 50 and 100. And so it returns a value of 103. It tries to set the value to 103. In that case, the model would reject it and perhaps peg the value at 100. So where the error handling gets done is rather flexible. Sometimes people put it in the controller, sometimes people put it in the model, although generally you want to avoid letting the user make a mistake, so it's typically better to put it in the controller. Okay, then you have the for each. So then you have to have actually a method in the model that basically walks through the views and notifies them. So essentially what it is this one right here, essentially for each an element of views or view list, okay, call the right notification method. And normally you pass the old value. The view can always get the new values because they're there, but you have overwritten the old values. So normally you provide the old values to the views in your notification method. And that is so that the views can, for example, damage the old region and only redraw the old and new regions rather than redrawing the entire display. So, or for example, let's say you're changing a choice from rabbit to dog. Then the view might need to remember the fact that it needs to unselect rabbit while it is selecting dog. So there are cases where the view might need access to the old values, but since they've been overwritten by the model, they can only get the new values. So generally, the arguments passed to the notification method are the old values that changed. Okay. And as I said here, for each method in the listener interface, there's going to typically be a notify M method that your change methods call in the model. So you change the slider value, you call a notify change slider method perhaps, and then it walks through each view and calls the notify method for it. Okay, so those are the methods that go into the model. Then the view has a couple of things that it has to do. In the constructor, so in the constructor, it is going to register with the model. So the model has these registration methods. So in the constructor for the view is going to call that registration method passing the this pointer, because that's a pointer to the view, so that it can be added to the model's view list. Then the view also has to implement the listener interface and repaint the affected screen regions. Okay, so it's fairly easy if the view consists entirely of predefined widgets. So in your homework assignment, one of the three views will consist of a J label. So it will automatically redraw itself when you update the text value. So that view will be pretty easy to implement, because all you'll have to worry about is changing the value of the widget, the J label, and it will automatically update itself. But the other two views, you might have to do some updating. I forget how I implemented my slider view. I know for a fact the gauge view, you will have to have some custom you'll have to have a custom paint component method. You'll have to call repaint after you've made the changes. So there you'll have to explicitly call repaint, not paint component. Remember, you never call paint component, you call repaint. Okay, and then finally your controller implementation, which will be part of the view, is going to be generally a series of event listeners. So typically your controller is going to be a set of event listeners. And they will call change methods on the model. Okay, so that is the implementation. I'm going to go through an example, but before I get to the example, any questions for me? Okay, so let me, in that case, go to the example. So my example is a very simple one where you're going to be able to looking for the glue class, and it is choice MVC here. Okay. So very simple. It's two views. I'll make it bigger. So two views. One is a set of radio buttons, and one is a spinner. I know it's really hard to see the spinner over here, but it is a spinner. So I can select here horse, and you see down here horse immediately comes up, or unicorn. Down here I can do my spinner, and it's going to spin through the different choices, and you see the radio buttons changing. Or I can type in something and it changes the both views. So I have two views, one with radio buttons, one with a spinner view. And the underlying model is one variable, which is the current choice. So the model is very simple. It's just one choice. I have two classes I'm going to have. So you can see here, I have a spinner view and I have a choice view. I'm sorry, I have a button view. And then I have my choice model right here. This choice MVC is my glue class. And my choice view, you'll see, is actually the listener interface. It is the set of methods that the spinner view and the button view are implementing. Okay, so also notice I put this in the MVC package. So you're going to see that all my files have a package MVC at the top. I am in the MVC directory, but if I tried to execute that and had just said Java choice MVC, it would not work because it's in the MVC class. If I simply said MVC dot choice, it still would not work because now it's looking for a MVC directory in the current directory, and there is no, if you look here, there's no MVC directory in the current directory. So that's why I had to say CP for class path, told it to go look in the parent because the parent directory is MVC, and then the fully qualified name of the main class is MVC.choiceMVC. Okay, so let's take a look at the choice model first. And you will see that it has one piece of state information, which is the current choice. It has a list of observers. So you often hear people talk about either the observer model or the listener model. They're referring to the same design pattern. So it's a design pattern where certain objects are listening or are interested in changes that occur to another object, and they want to be notified when that change occurs so that they can take some action. So the event listener model is another example of the listener or observer model in Java. There you have objects that are interested in the events being generated by event generators. Here, the views are interested in change information out of the model. So I have a list. The choice view is the interface that all my views are implementing, and I will store them in an array list because I very rarely delete. So even though delete could be a little bit expensive, we tell you normally don't do that in an array. When it is so uncommon, as it is here, and the number of observers is so small, that's not an issue. So then here's my one query method that allows the views to figure out what the current choice is. And here's my one change method that the controller will call to set a new choice. You see that I save the old choice because I'm going to overwrite it. I overwrite it with the new choice. And then I did not have a separate call to a notification method. Instead, in set choice, I simply iterate it through my observers. And for each one, I called the update method, passing the old value. So I'm perfectly fine in your homework assignment with your combining the change method with a for loop that iterates through the views and calls the appropriate change method in the view. No problem with that. Even though I showed it as being a separate function in my notes, if it turned out that this had to be done multiple places, you would probably move it off to a function rather than writing the for loop multiple times. And then here's my registration method. So that allows a view to add itself to the model. And in this case, I'm not worried about removing views or deleting them, so I don't have a remove observer. But if I wanted to allow that, I would have a remove observer method as well. Okay, so that is the choice model. Any questions about it? Okay, so let me then move on to the view interface. So here's that interface in a separate file, and all views will implement it. They will all implement this update method so that they can update their view to reflect the new choice, and also, if necessary, deselect the old choice. So very simple, but it is in a separate file, and I expect in your homework assignments that you'll put the interface in a separate file. Now let's look at each of the views. So let's look at the button view. So I'm having it extend a JPanel, and it's going to see it implements choice view. And there is a bunch of buttons. So here you can see my declarations for the 5 buttons. You can see I have a pointer to the model. Please never use private. After telling a bunch of you in the exam not to do it, I unfortunately did it. So the problem with using private is that it destroys inheritance. If you ever tried to extend this button view, you would not be able to look at the dog, horse, rabbit, tiger, or unicorn variables because they're private. And that defeats the purpose of inheritance, which is you're supposed to be sharing your implementation. So please get away from this nasty habit of using private, which unfortunately I did use here, and I will change that. Okay, I created a font that's really not that interesting, except it shows you that you can create new fonts. You see that the constructor needs to take a pointer to the model so that it can create a pointer to the model so that it can query the model as necessary. So every view is going to have a pointer to the model, and it needs to add itself to the observer list for the model. So that's a good use of this pointer. Okay, then I had to create the buttons. A button group allows me to group a number of buttons together so that only one of them can be selected. So that's the way I tell Java that these 5 radio buttons are mutually exclusive. I add them all to the same group called animal group. Okay, I set the border for my JPanel. You can see I add the different buttons to the group. The dog is the initially selected one. That was kind of bad that I hard-coded it. Ideally, I would actually ask the model what the selection was. Okay, you'll see that I do combine the controller with the view, and I set up the controllers in the constructor. Okay, so that's maybe one thing that I should write down explicitly, is that controllers are created in the views constructor. Okay. So here I'm setting up for dog. an action listener. So every time that I select a button, a radio button, it emits a action event. And the action I care about is action performed. That's what is being emitted. And you can see that I am calling a callback procedure called dog action performed event. So let's go take a look at it. And it's a one-line function. This is disgusting. I should have just put the method body in the listener. I have no idea why I did it this way, but I did. So I set the choice to dog. So you can see for each of the controllers, they're calling the model with the appropriate set choice. There is no way to avoid the action listener for each button. I basically do have to have an action listener for each button. Maybe if I got a little clever, I could figure out a way to only do it once, but I wasn't that clever. I just basically did copy and paste 5 times. Okay, so that, I believe, does it for, not quite. I have to implement update. So when the model calls update, that's me implementing the that interface. I get the new choice. I don't care about the old choice. I get the new choice. I do a switch. You'll notice I didn't actually discuss this, but in Java, you can actually do a switch on text strings. So I'm doing a switch on the text string, and depending on which text string I get, I select that radio button. The button group that you saw me create automatically takes care of deselecting the old choice. If I had not used a button group, then I would have to manually deselect the old choice. But since I used a button group, that's not necessary. You don't need to use a button group on your homework assignment, but just telling you that's the advantage of using a button group with radio buttons. And I believe
Dr.
that,
Vanderzanden,
yes.
if we had inlined those like animal action performed ones that you said were disgusting, instead of calling what? Yeah, instead of calling each of those, would we have just done model.set choice with the string right
Yeah,
there?
you would have just said basically model.set choice dog. That's why I called it a disgusting design decision on my part, because I essentially force you to go to another place in the file to look for a one-line action. So it ruins your concentration. It's just, it was.
And there's not any chance of that model.set choice function you made being reused, right? Like that is just there because it's extra plus, right?
Because it's what? It's
because it's just extra.
Well, it's not extra. It's basically how I tell the model what the new choice is. So views don't communicate with one another. Views communicate with the model, and then the model communicates back to the views. So if I don't tell the model that the new choice is dog, the spinner view won't get updated. So it's not an extra action. It's I guess maybe I'm not understanding your question, but it's a necessary, I have to call. So when I select dog, I really do have to call the model to set the choice to dog, because if I fail to do that, then the spinner view will never be updated.
Right. I think I just poorly worded my question. I understand what you're saying. Thank you for going over that.
Okay. You're welcome. Yeah, so I really have no problem with your inlining this kind of stuff. I must have written this at a time when I know I went through an evolution as a programmer, and I remember that there used to be, I think, something about how you always put your callback procedures and you separated them. But this is like as I said, I think idiotic to have one-line functions. Okay, other questions about this view? In that case, let's take a look at the spinner view. So same thing, it's implementing a choice view, and in this case, it's extending a JSpinner. So, but again, it's implementing the choice view. Again, it has a, don't declare it as private, has a pointer to the model and the constructor. Same thing, makes the, we save a pointer to the model. We add ourselves to the observer list for the model, set a nice border, set the font. This is different, and unfortunately a little confusing. So some of the widgets have their own internal model. So this model right here is not the model I created, but it is a model that is kept by each JSpinner. And what I'm doing is telling the JSpinner model that these are the 5 choices: dog, rabbit, horse, tiger, unicorn. So just like we implement our interfaces using a model view controller, each widget sometimes is implemented using a model view controller model. So in this case, the JSpinner model is being told that the contents of the spinner are the 5 strings: dog, rabbit, horse, tiger, and unicorn. And for a spinner, the event that gets generated is a change listener. Whether you type in something or you select one of those up-down arrows, it generates a change event. And that method is called state changed. And we call the animal spinner handler in that case. So let's see what it does. Disgustingly, it's a 2-line function, so I should have just inlined it. So we get the model from the spinner, and we have to downcast it to a spinner list model. And then we set the choice to be so this model, I know it's confusing, but this model right here is our model that we need to notify. So we're calling it set choice method. And we are getting the current selection from the list model get value. So we're getting the current value of the JSpinner's list model. I know it's confusing. There's no way around it. You just kind of have to do the bookkeeping in your head. Okay, so again, back here with adding the change listener, we're creating the controller in the constructor for the view. Okay, and then the last thing, that constructor, again, what the constructor did essentially was, so a view constructor, we can kind of summarize what happened. It needs to save a pointer to the model so that it can query the model. It needs to register with the model using the this pointer. Okay, it needs to set up, create any widgets. And or state information. And it needs to create constructors, or controllers rather. So that is what you saw going on in each of them. Okay. Then coming back here, very bottom, you see update. So that again is implementing that view listener. All we do is get the choice from the model. We call set value, which sets the JSpinner's model to be the current choice. And then the JSpinner automatically updates itself with that choice. Now, what you're not seeing here, and what you would need additionally, if you were writing the gauge view in homework 2, I'm sorry, in homework 6, problem 2, you would also, for that one, need a paint component method. And perhaps a get preferred size method. Those are two things you did not see overridden in my 2, but for your gauge view, you will need to do that. You'll need a paint component and probably a get preferred size method.
Dr. Vanderjagt,
Yes.
could you go over again quickly why you need to pass the old value to the update method?
Okay, yes. So I know I ignored it both times, so it doesn't really seem to be an issue here. But let's say in the button view that I had not bothered to create this button group and instead had manually decided to handle selecting and deselecting the radio buttons, then it would be helpful if I were told by the model which of the 5 animals had been previously selected. Now I understand I could do, maybe I could keep that information here, but if the model is already keeping it, why keep it in 2 different places? Or let's say that I had a rectangle and the model tells me to move it over here. So I move the rectangle from here to here. I might like to know what the old value of the rectangle was so that I can damage this region and then damage the new region. Now, of course, again, maybe I'm keeping this old information in the view, but maybe I'm not. So I guess the bottom line is oftentimes that old value is not necessary because the view is already keeping that information, but you can make an argument, why are you storing the information twice? It can get to be a big waste if you have end views storing the old value and the model storing the old value. Why not just store it in one place and then have and then provide it to the view when it needs it? That's the argument, okay? In practice, I think a lot of people just store that information in the view and they just ignore the old value that's passed from the model. But that's the theoretical reason behind it, okay?
That makes sense. Thank you.
Okay, you're welcome. Okay, I need to move on to the glue. So that is the last of the classes that you need to create. And I call it a glue class. So it needs to create the window. So here I have it extending a J-frame. If you want it, you could instead just create the J-frame in the constructor, which is what I did in the lecture on Tuesday. So that's an alternative way that's just as good, is to create the J-frame in the constructor. But here I had the glue class extend the J-frame, so we're automatically a window class. Then I created an instance of the model, my choice model, and assigned it to model. And I'm going to init my components in the constructor. You can see init components creates the 2 views. So that's what I said that the glue class had to do, create the 2 views. It also created the model up here. It created the two views. It sets the option for closing on the main window. I decided to use a grid layout for the content pane. So I changed it. Normally it's a border layout and it would have worked just fine here. But to show you a different layout manager, I decided to change the layout to a grid layout. This says that there are unbounded number of rows. 0 doesn't mean there are 0 rows. It actually means there's as many rows as necessary, but only one object per column. So if there's 2 objects, there will be 2 rows because you need 2 rows of 1 column each. Then I added my 2 views to the J-frame, and I called pack to get the window at its natural size, and that was pretty much the setup. Okay, and here's my normal idiom in main. I defer actually running the constructor until I am done executing main. So I call this event queue.invoke later method, which you basically just copy and change the contents. This was disgusting. I should have set visible up here. Why I did it there is beyond me. Just really should be like that. It worked just as well the other way. Okay, so that's the glue class. The glue class, I think I already told you, but maybe I tell you what the glue class does. Yes, glue class contains main, creates an instance of the model and the view classes and links them together. And I should have added something right here, adds views to the window. Because the views don't magically appear, they have to be added to the window. So that was something that I missed in the glue class, adding the views to the window. And notice that when I created the views, that I passed in an instance of the model. So when I'm saying I'm linking them together, the constructors for the views saved this pointer, and then they called the add listener or add observer method, and that's what linked them all together. Okay, so you're going to hopefully go through that same thought process for homework 6 on problem 2. So if you're having issues, maybe come back to this lecture. I will post these files to Piazza so that you can use them as a guide. They are a very good template for setting up your own application in homework 6. Just remember that the gauge view, you're going to have to define, I believe, these. Well, I know for a fact you'll have to do paint component. You also need to do get preferred size. Okay, so with that, I'm going to let you go. I will probably not worry about sprites for this class. It's just not that important. Tuesday, this is the end of GUIs. So at this point, you hopefully have a rudimentary understanding of how to create a graphical user interface. And on Tuesday, we're going to pivot and we are going to start talking about Python and scripting languages. And again, I will be back in Mingao on Tuesday if you want to attend in class again, but it's still, I'll have the Zoom as always, and you're free to continue to participate online through the Zoom meeting. So have a great weekend. Remember, the homework's pushed back 2 days, so it's not due now until Tuesday evening, but still make sure you don't put it off to the last minute because I know for a fact that this homework assignment and the final homework assignment in Scheme are the two hardest ones with the lowest scores of any of the homework assignments. So you really need to get started early. Okay, so I'll let you all go. Feel free to stick around to ask questions.